I'm Jack Christensen. I recognize several faces from the first meeting. Who wasn't here the first meeting, just so you get an idea? Okay. Adrian wrote me into doing a little talk on microcontrollers, so that's what I'm going to try and do today. I'd like to get a little level set first as far as, what you folks' background is maybe. I know a couple of you have played with some microcontrollers before, so anybody know or have touched a microcontroller? Okay, good. Okay, and what about Arduino? In specifically? Okay, good. So I didn't know what to call this. I was going to call it 101. I thought, no, that's too pretentious. So I thought something like that might be better, and the point being, I am not the expert, one of the experts that Adrian has promised you. This is just a hobby with me, so take it with a grain of salt. My experience is pretty much limited to the Atmel line of microcontrollers, which are what's used in the Arduino projects. So I spent way too much time in corporate America, so I apologize for the PowerPoint, but it's stuck, and that's the only way I want to do things. So I'll try to move through this pretty quick. I'm going to go over some general information about microcontrollers first. I'm going to spend a little time on the Arduino microcontroller and its relatives, and then I have several demos and a couple of my projects that I want to show you. And then we can do questions and answers. I want to keep it informal, so if you've got any questions along the way, or if you can't hear me, can you hear me in the back? If I mumble, yell. And if there's any questions along the way, don't feel shy, shout on. Okay. So what's a microcontroller? It's a little bit of a new word for some people, maybe. I think a lot of people have heard of microprocessors, because that's what's in our PCs and stuff. We've heard microprocessor for a long time. And the difference is that the microprocessor itself is only the central processing unit of the computer. The memory is separate. The storage is separate. If you've ever torn a PC apart, you've got separate memory cards. You've got the disk drive is separate. Whereas a microcontroller is a complete controller, all in one chip. It's got the central processing unit, it's got its own memory, it's got peripherals to do I/O with, and it can communicate with the outside world. And importantly, the reason they call it a controller, and what makes it fun to work with, is it can actually control things. I can read information in from sensors, and I can control actuators. Like I've got a servo motor here. It could just turn a light on and off. It could be a valve or anything like that. So the one I'm going to talk about a little later is this guy here. That's the microcontroller that's used in the Arduino boards. It's got 28 pins, and it's amazingly cheap piece of technology to have all that stuff in it. It's pretty amazing by that itself. Microcontrollers are used in embedded systems as opposed to general purpose systems. So what's the difference? Well, my PC is a general purpose system. I can do whatever I want. I can do PowerPoint if I have to. I can play games. I can surf the web. I can do a lot of things like that. Whereas a microcontroller has a single purpose. It only does one thing. It only has a single program. And usually it has no operating system either, although there are exceptions to that. And there's a whole spectrum too. This one that I've got here that's just flashing lights is way on the small side of the spectrum, whereas you can get up into some fairly powerful embedded systems now. Especially, one of the things you might see is if you go out and buy a Wi-Fi router. Now, those are coming as multiple core systems. They're probably running Linux inside, and they can have 2 cores, they can have 4 cores, some of them I think now. But that's still considered an embedded system because it only does one thing, right? Some of them aren't hackable, but the intent is to do one thing, usually no operating system. And this is kind of a bit of an old statistic, but in 2002, over half of the CPUs produced in the entire world were microcontrollers. Okay. And so some of the companies, you know, if you're not in a tech industry, you might not know some of them, but everybody's heard of Motorola, Texas Instruments, things like that. Renaissance is actually a really big dog in the automotive microcontroller market. Last is that now. I didn't put them last because I hate them, but because I'm going to talk more about them later. Like I said, that's the company that makes these microcontrollers that I'm using here, the ones that are in the original products. Right, so why haven't I ever seen one of these things? That's some of you have. But they're inside everything. They're doing things just about in every appliance probably that you've bought in the last decade at home. You've got at least one microcontroller. If it's a microwave oven or a refrigerator, my refrigerator's got these cool LED lights that dim when you open the door and stuff. That's a microcontroller doing pulse width modulation for those light-emitting diodes to make them dim like that. So the simple things like that, washing machines and so forth. Cars are huge. I mean, there are literally probably dozens of microcontrollers in cars anymore. Controlling the engine, controlling the transmission, controlling the ride, even starting the car. I mean, in the old days, you had the ignition switch and a relay, and you complete that circuit, and it connects the battery to the starter mode. It doesn't work that way anymore. It hasn't in a long time. A couple funny stories. We had this is 15 years ago now. We had a car that I don't think it got recalled, but it was one of these things saying, well, we want to update the software in your engine control module, right? So we take it to the dealer, and they do their thing, and I drive back with my wife, and we pick up the car, and we're driving home on the expressway, and my wife is a very conservative driver, and I was ahead of her, and I'm driving along, minding my own business, and she blows by me, doing about 90. And so when I get home, I said, you know, how fast were you going? Oh, between 65 and 70. They had put the wrong program in the car. The speedometer, even though it looked like the old analog speedometer that used to hook mechanically to the transmission with a needle, that thing was being controlled by the software. It was really just a servo motor in there. And she thought she was doing 70 and she was doing 90. So another trip to the dealer. And a couple other funny ones, but I'll save those. So they're used for that kind of thing. I mean, there's entire networks inside your car. And there's another good story about that where I think it was a Cadillac. They had rolled out some new models for the bigwigs at GM to check out of the pre-production prototypes. And they had these things out there and they're supposed to be fully functional. And one of the bigwigs got in, turned the key, and nothing happened. And of course all the engineers were embarrassed, but when they went back to figure out what was going on, what they found out was that the Bose speakers that were on the LAN, the network in the car, were interfering with the information being sent by the ignition switch. And that's why so that car wouldn't start because of a software problem. And of course everybody's heard of all the kinds of stuff that goes on. You know, their cars these days get recalled and going when they shouldn't, and stopping when they shouldn't. So that's a big thing. I talked about sensing the environment and doing actuation or other control. Internet of Things is a big buzzword these days. I've got a demo here about that a little bit. Anybody heard that one? Internet of Things? Basically, this is a matter of connecting ordinary, everyday things to the internet to let you know about things. Project I did myself, if my sump pump quits working right now, I will get a text message because I got a couple of these microcontrollers watching my sump crack. If the water level gets too high, it sends a text message over the internet and lets me know. So that's really big. It's kind of up and coming. It's just in its just in its formative years right now. The IEEE does have some working groups on it, and so they're getting pretty serious about it. A lot of companies, you're seeing the buzzword used by a lot of companies. So it's up and coming. I don't know that I need my toaster to talk to my refrigerator. You know, I don't know if that's a good application, but there are some good ones out there. Robotics, quadcopters, those have been in the news a lot lately too, spying on people. But the hobbyists have been fooling them for some time now. And you've got this whole makers movement, which I guess sounds like this Flint Steamworks. I haven't been to one of their meetings yet, but it sounds like that's kind of what they're all about. A lot of this technology is really engendering a return to do it yourself, which is a lot of fun and really cool. Specifically, the Arduino microcontrollers. This fellow Massimo, one of the inventors of it, talks about physical computing a lot, and he just means interacting with the environment. But the interesting thing about Arduino is it was originally targeted, or one of the main targets for it was artists and people that didn't know the first thing about programming. So they really did a good job in making it very, very simple to get into. And do interactive art kind of things, whether it's light, motion, that sort of thing. So this is the quote from the Arduino website. That's what they say an Arduino is. Any questions so far? I'm doing all the talking. Am I talking too fast? That guy there, that's the model. They call it Uno for number one. Made in Italy. They have a lot of different models. There was several predecessors to this. This is probably the most successful one to date. They got all the bugs out with the predecessors, and this is kind of what everybody starts with. Rumor is Arduino is the bar in Italy where these guys thought the thing up. So I don't know. It's interesting. I can't swear to it. Like I said, they have very many boards now. There were some predecessors to this. The Uno uses that Atmel 18MeG328 microcontroller that I showed earlier. Last couple of years, they have gotten into all kinds of different platforms, including some ARM devices. They've gotten on board with Intel, and it just goes to show you how much attention the really big companies in the industry are paying to the whole maker movement. I'm going to give you a little bit of technical stuff on this particular microcontroller. It's part of a family that Atmel makes. There are 8-bit machines. They call it the AVR family. It's a modified Harvard architecture machine, which means that it has separate memory spaces for the program versus the data. So the programs in these things are stored in flash memory, just like we would use in the flash thumb drives that we like to use to move our data around. That's used for the program memory. There is also some static RAM memory that is used for transient data and stacking and that sort of thing. The thing you notice here is that these numbers are a lot smaller than what we're used to dealing with PCs. Right? This PC here is a fairly recent model. It's got 8 gigabytes of memory. This microcontroller has got 32 kilobytes. The PC has got 262,000 times more memory than this does. So that's where people say, well, what the heck can you do with that? And the answer is you can do an amazing amount of stuff if you don't have the overhead of an operating system, if you don't have a graphical user interface that you've got to run. Using C and C++ programming languages, those are very memory efficient. I can pack thousands and thousands of lines of C++ code on one of those things. It's really amazing. It also has 23 programmable input-output lines. So of the 28 pins, 23 of them, give or take, there's some technicalities there, 23 of them can function as inputs or outputs, which means the code that runs in here can tell if the switch is turned on or not. And then there's also an analog to digital converter, I'll show you a little bit of that later, that can sense analog values. So one of the sensors I've got here is a light sensor. So it's going to give me a number instead of just a digital 1 or 0 and on or off. It's going to actually give me a number between 0 and 1023, telling me how bright the light is. So an analog value rather than a digital value. It's got the ability to communicate in at least 3 different ways with the standard hardware that's built on that chip. You can do even more if you want to program your own in firmware. But it can talk to other systems, it can talk to the PC with an asynchronous protocol, it can talk to other integrated circuits through a couple of other common bus architectures. One of the things I think is really exciting about it, and I play a lot with, is the low power modes. For battery power projects, low power is obviously really critical. And one of the really cool things you can do with these is put them to sleep, but they're still kind of listening to what's going on in the outside world. They're waiting for an interrupt, they're waiting for a match on a communications bus. Somebody wants to talk to them on the bus. And while they're sleeping, they draw an amazingly little amount of power. This guy right here, I don't know if the lights have been flashing, but when the lights aren't flashing, it's not off, it's sleeping, and it's only drawing about 1/10 of a microamp. That's so low that if it slept all the time, the batteries would basically not even notice it. The batteries would last whatever their shelf life is, 7 or 10 years, or whatever Duracell is telling us this is. So the low power features are really cool, and there's a bunch of other stuff that goes on too. I won't get into too many details. So I'm retired, so I'm cheap, I don't have any money, I don't have a paycheck anymore. So I always say, oh, that's great, how much does this cost, right? And it's amazing how cheap they are. If I buy one of these from an electronics distributor, it costs me less than $3. If I wanted to buy a couple dozen, it's down to $2 a piece. A lot of technology for a couple of bucks. The Uno board itself is around 25, I think, on most of the sites now. And it's got all the support circuitry that it needs. It's got some power supply components. It's got connectors for your inputs and outputs. So it's not a bad deal at 25 bucks because it would, while I could do it cheaper than that, it would take me time. My time is still worth a lot of money. So there's the Uno. The big brother is called the Mega. That's actually got a whopping 256 kilobytes of memory. And that's about $45, $46. You can buy clones. Remember, you need one of these out here. Let me pull this out by the roots. This is a clone of the Uno. This is from a company called Adafruit. You guys have heard of Adafruit, right? This is made by a lady in New York City. Her name is Lamore Freed. She goes by the handle of Lady Ada. And it's been very successful. And she's got a really successful company going. She's been on the cover of Wired and Forbes, and I don't know what else, how much she's on the cover of Forbes. Just dozens of different business outfits like this, magazines and publications. This is a really nice, compact clone of the Uno. It goes for, I think, $17.95, so it's a little less. Done a really nice job on it. So there's a lot of this kind of thing out there. And then some of the bigger ones, I mentioned that they've really branched out in the last couple of years. There's an ARM-based board now called the Arduino. Who speaks Italian here? Nobody? Oh, I'm safe. I don't know if I think it's a duet. Is that two in Italian? Two? Oh, no, okay, good. So that was kind of their second major thing. They've got one out that's actually it's a dual machine. It's got a Linux system on a chip that talks to an ATmel microcontroller. What some people found was some of the small single board computers, while they were okay as general purpose computers, actually pretty good as general purpose computers, they didn't have some of the I/O facilities that microcontroller people were interested in and used to using. So they built this board that has Linux on one side, an ATmel microcontroller on the other side, and allows the two to talk. So the microcontroller does what it's good at. On the other hand, you have the power of Linux. If you want to run a web server on it, go right ahead. I think I also mentioned Intel has got into the thing. I don't know a lot about that one. The other thing that goes on is there's all kinds of variations, mostly of the Uno. There are variations where it's basically the same machine, same board, same capability, just a different form factor. Okay, this is called the Arduino Pro Micro. And they are about $10 right now if you buy them from Fruit or SparkFun or one of those kinds of places. But it's got the same microcontroller. It doesn't look the same. It's in a different package. This is the thing that goes on in the semiconductor industry, is companies like ATmel will make a chip in several different packages. So this is a more compact package, more compact board. And I mentioned clones, lots of clones out there. The thing, I'm going to work into the demos now. I'm running longer than I hoped. Is that all right?
Yeah.
Is that okay with everybody? The thing that Arduino has been it's really been a juggernaut over the last 10 years. And they started about 10 years ago. The Uno came out probably 4 or 5 years ago. And since then they've gone in a lot of different directions. But the thing that really made them successful, and I'm going to program one of these Unos for you, show you how it's done. This is just another Uno like this one, stuck on a piece of plexiglass with a solderless breadboard, so that we can hook up some circuitry to it. But all I need to do to program one of these is buy an Uno, buy an Arduino, and then I need to download and install the integrated development environment called the I, which is free. It's on the Arduino website, and I need a PC. That's all I need. Our Arduino it's scaled back, it's pretty simple-minded, but at the same time, they've preserved a lot of capability and power with the thing, and I think that's really what's made them successful. It really is quite an interesting success story. So, this is one of the things I hate about Arduino. This is about the only thing I hate, is they made up words for things. When you program the microcontroller, you write a program on the PC and you download it into the microcontroller. They have their own name for that. They call that a sketch. So if I say sketch, don't get confused. That's the program. And that came out of this. That really came out of this artsy kind of market that they were targeted at initially. And still are. The other word they like to use that I don't like is shield. Here's a shield. I have another one here. But that's just a daughter board. And what it does is it plugs into the connectors on the Uno and gives you some sort of extended functionality. So if I say shield or sketch, and I don't mean to say them because I hate those words, but that's so you know what they are. The other shield I have here is an Ethernet shield, which is pretty cool because it gives my microcontroller the ability to either be a web server or a web client. I've got this guy hooked to actually, it's a wired connection, but I've got this little dinky travel router that is got it connected to the Wi-Fi here too. Still is, but so we'll look at that. Questions so far before we get into the demo? Who's a programmer in here? Who knows what hello world is? Who doesn't know what hello world is? Everybody knows hello world? All right, good. Microcontroller people have a little different version of hello world. And instead of actually going and printing out hello world, microcontroller people like to make a light emitting diode blink. And so I have an LED here. I'm going to plug it into my breadboard. And I have a resistor to limit the current to it. LEDs don't like to have too much current pass through them or the magic smoke will come out. I'm going to hook it to the ground. And I'm going to hook it to pin number 8. So that when the microcontroller turns pin number 8 on, the LED should light up. Okay. So this is the Arduino IDE, the integrated development environment. And I'll plug this in. And all you need is a standard USB cable. So I'll plug my Uno in like that with the LED hooked up. Now, every Arduino sketch must have 2 functions in it. And this is, if you know C, if you know C++, these are not foreign looking constructs. So every Arduino sketch must have setup and loop functions. Okay, and if you program C, you say, wait a minute, where's the main? Okay, well, Arduino isn't quite a vanilla C environment. They hide main under the covers. Okay, and all main does is it calls setup once, and it calls loop over and over and over again. That's the other thing about embedded systems is they never stop. You know, I might run PowerPoint, and I'll use it for a while, and I'll shut it down, and it's done for the day. Microcontroller, as long as it's on, it's running because it's doing something. It's waiting for input, it's controlling outputs, all that kind of stuff. So what happens in an Arduino program is, like I said, the setup function gets called once, and that's where you do one-time things like we need to tell it that the LED is on pin 8 and that I want to treat that as an output. So this is, I mentioned earlier, how they've made things pretty easy. This is a one-page summary of the Arduino programming environment. And this has got pretty much everything you need to get started on it. And it's a mix of stuff. It's a mix of standard C, C++, along with functions that they've written to make things easy to do. Okay, so you know, your control structures, your if, else, your do's, your fors, all those kinds of things, data types, all that stuff is standard C. Over here under functions, you'll see I've got digital I/O, analog I/O, and so forth. I've got some timing functions down here. I'm going to use a couple of these in this sketch to make this LED. Okay. So the first one I'm going to use, I'm going to call a function called pin mode. And like I said, I'm going to do this right. I'm going to declare a variable up here. Okay, just a variable saying my LED pin is pin number 8. And I'm going to say, make that pin an output pin. That'll happen once, and then loop will get called over and over again. Here's where we're going to turn it on and off. So I'm going to use a function called digital write. And I'm going to use a function called delay, which takes an argument that is milliseconds. So this is saying delay for 1,000 milliseconds, which is 1 second. So those two statements will turn on the LED and wait for a second. And then all I need is 2 more statements to turn off the LED and wait for another second. And I can compile my program or sketch. See if I did it right with electronic speed here. Didn't see any errors, so I'm good. I will click this button. You can see how simple this development environment is. I'll show you the big dog as comparison. This is Atmel Studio. This is the development environment that you can download for free from Atmel's website. You can use this to program any of their microcontrollers. And it's actually built on Microsoft Visual Studio. So if you're familiar with that, if you're familiar with Eclipse, this looks familiar.
Is it built on what? Microsoft what?
Microsoft Visual Studio.
Oh, okay.
I think so. Yes, I don't want it. Okay, that was painful. But I mean, as you can see, this versus that, right? If I were somebody that had never programmed anything before, that could be a little bit intimidating, right? So that's where they've really done a good job. Okay, so I compiled this, it looks good, and I'm going to upload it to the now. There it goes. And my LED blinks. So that's how easy it is to program. That's all you need to do. That's kind of all I wanted to show as far as actual programming today. You know, if there's further interest, you know, be glad to talk about that. I don't want to usurp all your time here. So let me see where I was. Okay, I'm going to talk about a couple of these projects I've made. This is actually a practical joke of sorts. It says warning 1 million ohms. If you know anything about electricity, 1 million volts is not something you want to mess with, and 1 million amps, but 1 million ohms is not going to hurt you, okay? Ohms being the unit of resistance. So this is designed, if you want to keep somebody away from your workbench, you just set this on your workbench and it keeps you uninitiated at distance. This uses what's called an AT Tiny 85 microcontroller, which is a little brother of Arduino. It's got a mere 8K, 8 kilobytes, 8,000 bytes of program memory. And it is terribly underutilized, just blinking LEDs, because it still has analog digital converters and pretty much most of the ability of its bigger brother there. Not quite as good on some of the communication stuff. You got to do a little more software than hardware. But for $1.40 a piece, I don't feel too bad just blinking LEDs. A little more complicated project that I did. This is a data logger. It uses the same microcontroller as the Arduino. Runs off of 2 AA's. Takes advantage of the low power aspects of the microcontroller. And it's got a prototyping area over here where you can solder in whatever sensors you might be interested in using. This one's got, right now it's got a temperature sensor and a light sensor. The funny story is, this is actually my buddy's project. He had a cabin up north. He wanted to monitor the environmentals up there all winter long when he's not there. And he had this lash up with an Arduino. And it turns out an Arduino board isn't the best thing for low power, because there's a lot of stuff on there other than the microcontroller that draws power all the time. So if you really want to go low power, you kind of got to roll your own. So anyway, my buddy he was supposed to be here, but I'll talk about his thing. He had this lash up with an Arduino and car battery and solar charger, and it still wasn't making it through the winter. I said, Tom, we need to think about this, do a little better. So this is what we came up with. And he ran 2 of these for 6 months in his cabin last winter, and they hardly put dent batteries on it. This thing will sleep until it's time to take a data sample. It will wake up, store the data in some non-volatile memory that's on board here, and go back to sleep. And it might do that once a minute, once every 5 minutes, so you can program it however you like. But it doesn't take more than about 15 or 20 milliseconds for it to wake up, read the data from the sensors, store it in the memory, and go back to sleep. So, like I said, I don't even worry about putting fresh batteries in it most of the time. Also wanted to show you just real quick, the other thing, and this is another thing that's really fueling the maker movement, is the ease with which a person can make printed circuit boards. Here again, free software, as long as you're a hobbyist type. This is called Eagle. It's a printed circuit CAD CAM package from a company, I think, in Germany called CADsoft. So this is actual schematic diagram of my Lincoln board. It's got the mic, it's not much to it. It's got the microcontroller, it's got a couple switches, resistors, and LEDs. And then the board actually looks like that. And the neat thing is I can design it on my PC. I can ship the CAM files off via email or a website to a PC fabricating outfit. Never talk to another person, and in a couple, 3 weeks, they're in my mailbox. So I used to make printed circuits in my basement, so when I discovered that, it's like, gee, I don't have to mess with these chemicals and make mistakes, and I get a much more professional quality product. So that's Eagle, and I've got 2 more things I want to show you.
Did you say that Eagle comes from CADsoft? Is that the name?
The company that makes it is CADsoft, C-A-D-S-O-F-T. One of my favorite things is wireless networks. I got a bunch of these around the house. This is a wireless mesh networking module that you can use to communicate between a couple different microcontrollers. They're implemented on an IEEE standard. It's actually kind of closely related to Wi-Fi, but they're a low bandwidth, low power kind of an implementation. The neat thing is you can have a bunch of these, and they create this self-forming and self-healing mesh network, which means if this guy wants to send data to this guy, these things all talk to each other, and they figure out who's closest, who's got the fastest route and everything. And so maybe the data's coming this way, but if this guy gets powered off, can't get there anymore, the network figures out how to get the traffic there anyway, because there's other routes. Kind of an interesting thing, the more hardware you add to the network, the more reliable it gets. So I've got a demo showing that here. Oops, I got to plug this back in.
Is that wireless mesh through Arduino? Your wireless mesh, is it through Arduino?
Is it?
Is that an Arduino sister board?
Yeah, this one, I'm using this plumb. And I'm using the wireless module just plugged in on this Cyrus breadboard or something. Did that answer your question?
Whether it was Arduino, manufacturer's Arduino?
Oh, no, that's made by a company called Digi, D-I-G-I, International. I got some links at the end, and I'll put this, I think I can put the presentation on the Meetup website. So I'll do that, so you don't have to worry about writing things down too much. Okay, so this is just a basic remote control application, which, you know, might just look like a,
Oh, it is connected or is it wireless?
well, there are 2 of them, okay? I've got a control board here that's going to control what's on this board. So if I push buttons here, I can light up a red or a green LED. And then I've got a potentiometer. If I turn the knob, it turns this servo here. And I apologize, it's an old potentiometer on my junk box and it's dying. But, you know, and that'll operate anywhere in your house, certainly. And,
But it's wired, it's not wireless, so it's connected.
they're not connected to each other.
Yeah, they are not.
They are not. There are two of these modules.
That's just power, right?
Yes, just
Yeah,
power.
I saw the
Just
port.
power, yeah. This guy is reading the switches and the potentiometer. He's sending the data over the network to the other one. So, we'll do a Q&A session when I'm done here, and y'all can come up and play with this order. The other one I want to show you is this guy, and this is a kind of an Internet of Things application. And this has 3 sensors on the board. It has the temperature sensor, which is the red line. This is a web page. Every 10 seconds, this is sending the data from 3 sensors up to the web. And this website is displaying it. Maybe my hands aren't. Let's see who's got the hottest hands here today. Okay, there we go. So I drove the temperature up on the temperature sensor. Here's a light sensor. And you can see every time it sends a packet of data on it from a counter here. It still senses some light even through my thumb, I guess. And then lastly, I have again, another potentiometer that I can twiddle the knob on. And that gauge in the lower left should react. So that's your basic how to get data out of a microcontroller up to the web.
Is that out the spy? Is that spy coming out? Spy. Is that spy?
I don't know that.
Serial peripheral interface?
Oh, the Ethernet shield uses SPF. Yeah, and the temperature sensor happens to be an I2C sensor, which is one of the other buses that the microcontroller will communicate with, and the potentiometer and the light sensor are doing analog input. Okay, so what you're seeing here is just the number, basically, that the microcontroller is reading off that.
Do you have to use a motor shield with your servos?
This is just a little tiny standalone servo.
Okay.
Yeah. I'm not much of a RC guy, so I don't know a whole lot about servos. I just had this one kicking around.
You think some servos, not so sure if I need a shield.
Yeah, I'm aware of those, and probably for the bigger ones.
Yeah.
Yeah. I found this at Sprawl Mart the other day. Dust your keyboard off. Some people call this canned air. It's not air, it's a refrigerant. This is actually R152A, difluoroethane. And if I get on this temperature sensor here, long enough for it to take a sample. Oh, we're not talking right now. I've lost my connection.
Yeah, that's
There you go. So what is that? I can't see it. What's our temperature there? About 160. I had this minus 25 degrees centigrade the other day. So be careful with this stuff. You can get frostbite. That's all I got. What questions do you have?
the 80s. Reading those values in. you're assuming that's where you're using I squared C for your ABC?
I squared C is for the temperature sensor as a digital,
Right.
and then the ADC is doing the light intensity and the potentiometer.
So the sensors for the,
Come on up here. This board is a temperature sensor. And then cadmium sulfide photocell. And then this guy and the pod are connected to analog inputs. The temperature sensor is connected to I can see one.
so there's no conversion board, it sends out the values.
It's
There's
digital.
nothing you had to do.
I probably converted it to Fahrenheit. So I think native mode is it does it gives you Celsius. And it's a temperature sensor here. And there's all different kinds. This is actually
Those breakers.
that one right there I built. That's a microchip.
Is it hard to build?
No, not if you don't mind soldering the surface mount stuff, which is really not that hard. That's actually got a couple. This is a couple chips on this. It's got a. It's got one of these chips is a temperature sensor. Actually, this is the temperature sensor here, and this is a match chip. It's a little EEPROM actually. But because I need a MAC ID for my internet, I can make one up. If I want to do it right, you can buy it from a order for this chip, right? And so the Microchip Corporation, they've actually bought the pool of MAC IDs, and they just put it on a chip and you can buy it. So if you have a product, it's, if you put a product on the market, you better darn well have a unique MAC ID, right? So that's what that is. So I'm using that. Yeah, that's actually not Wi-Fi, but it's actually it's 802.15. Wi-Fi is 802.11. Yeah, so you can hit these switches here. That's the other thing.
You do houses or lucky buy?
That came with a kit. Funny story. This is how I got into this. I bought my kids. Starter kit. I had no idea what it was. I read an article and said, hey, this is pretty cool. Okay, give me two. My daughter played it a little bit, my son kind of went, and then I got it. So it turned up being nice. But that came
And you had to get this guy here, is this?
yeah, you can get these. I got this at Newegg. I think Walmart sells these for like $20.
What is this guy?
It's not actually, well, it's got 5 different modes. It'll work as a small router. I'm using it.
Yeah, so like this is.
All
so
it's
this
doing is it's for a
like,
place that doesn't have a Wi-Fi connection. It's changing, it's just taking the wired internet.
Connected in
So that allows you to be able to type
These
it.
are so that these are so for the same.
Yeah, well, and this allows this thing to connect up
I
to.
have like a shield. It's not
Wow.
those two. There's probably like the that connects you to.
Are you gonna do the details of your hardware?
He's
I
probably
can, no, I'm more than
Yeah,
likely.
I appreciate it, man, yeah, you give me,
But there's like, so like on the internet, there's a lot of
This guy,
libraries
Yep.
stuff that you can look up for
Um,
your Arduino, and so you look up like temperature sensor with your Arduino. Yeah, you can find pretty much people post
Digi
videos,
is the,
so you can find like all
Digi
the
International.
tell you like what
International.
Digi International Basics, you can get them through
probably have to order the parts.
Mouser or
Order the
Digi
parts and you
Mouser.
just like basically.
But the cheapest place that I found these
Yeah.
is right
See,
there.
like, the whole thing too is
Actually, I
like-
think Mouser's price and DigiKey just started out. I think these cost me $17 a piece, which are for what they do.
Right, it's not.
Yeah, sorry, it comes with like servo motors, PC motors.
no,
I forgot one thing. My buddy sent me this as a gift, and I told him I would bring it. And I know nothing about this, but somebody here knows what this is, right? It's a Raspberry
It's
Pi.
actually,
Oh, yeah.
Yeah, this is a complete Linux system on chip. It's got 700 megahertz ARM processor. It's got half a gig of memory. It's got HDMI output. It's got USB input for keyboard and mouse.
Yeah, no, it's really easy to learn because
I had a question for you. How do you think learning types of voltage and current?
Yeah, definitely. Those microcontrollers will operate off of anywhere from 1.8 and 5 volts. Okay. Common voltage is 5 volts is common voltage, 3.3 is common voltage.
yeah.
You can see I'm running some of them on 2 AA batteries.
Right. A lot of these.
And they will use anywhere from, it depends on how fast you clock them.
Right.
And what the voltage is, but they'll use anywhere between, fraction of a million to maybe 10. The output pins on these are rated at 20 milliamps. So those sorts of things are 20 milliamps. If you want to go to 4 amps, you're going to need some kind of a relay or a MOSFET.
Look, I had it hooked up like that, and I just press the button and I'll get it on.
Let's tell these guys, I'm watching the kids at Burger King. They didn't get the road like It's got to put this on.
Yeah, so like what he had up there is called the.
So, are you doing control theory though? Are you doing feedback loops?
I haven't done a lot of
There's that checkbox.
That'd be,
You click that checkbox.
this part, I don't have it yet, but I've been playing with this inputs and outputs and I actually see spot. What I haven't done is the actual control theory and feedback.
just pretty basic. I mean, you can get way carried away and, what is it called?
So like when you took this, you just said you turn that circle, how do you know?
I don't. It's one way, it's an open loop. All I'm doing is, I know what's zero, that thing goes about 0 to 180. So all I did, this is just what the cross applied was, right? So, I just take the voltage straight off the slider. And I just convert it to. All that stuff is pretty straightforward, too. There is no stand-up. CL. No, there's another function.
It's not.
There's a,
So would it be like connected by Wi-Fi to the, okay. Yeah, you have to launch your
okay, that's,
How do we want to?
that's the water is going to operate at. Okay, so, and what I'm going to do down here is,
That's what Bobby uses for their,
that's print line, right? I'll just upload this, let me re-upload this. Millis, you know what millis is? Yeah, but it's the number of milliseconds since the thing started. So as soon as I.
Oh, really is, okay.
It's milliseconds. So what I'm gonna see here.
Oh, the time changes.
Yeah, so.
That's what you need.
When you get said,
Is our business that for twice a month?
so, yeah, they started to show.
Yeah, this is right here, you know.
I was a kid.
Help reference?
Alright.
I'm here for the bottom. Serial. Okay. And you've got, and then all your functions go with.
I got my board, but, I look forward to the next one.
I don't know where we want to go with it, we need to talk about that.
Yeah.
If we want to work, projects, I'm glad to do that.
Projects.
Yeah, absolutely. If we want to get some starter kits and work through the experiments on that, you know, whatever.
Yeah. So, I mean, projects after, start kids, share projects, conversation, and then I'm looking for someone to help, looking for projects, I'm willing to help them find a project that's.
I'm gonna put my email up here, so drop me a line if you.
Yeah.
Oh, those ones, the ones that you had up, are those? Okay, that's on the bottom.
That graph screen, did you program?
Okay.
That's actually an online service. There's must be 50 of them out there now. All these guys trying to provide platforms for the internet.
I would for
They use some package that they bought.
Yeah.
So he told me what it was.
So that's like,
John, nice to meet you, John. Did you come to the